Weather Shield is a family-owned business, just about 75 years old. We'll build windows, doors we have that are 8 foot by 14 foot, up to sliding doors. The largest one I've seen was 53 feet by 10 feet. The average home we go into is $2 million to $50 million homes and above. We bought our first 3D printer in 1995, the Stratasys FDM. We have a 450 now, and then about 5 years ago we switched to the Origin 1, and then about a year ago we switched to the Origin 2.
With the Origin 2, we're just stacking prints, interlaying them, being able to produce hundreds at a time.
This year we're probably going to use 30 to 40,000 parts in our production units out of our 3D printers. These parts are physically going into units that are seeing hurricane force winds that are up to 200 miles an hour. If you look at a house in Arizona, it can be 30 degrees overnight and 145 surface temperature in the day. The 3D printed parts don't have an issue with that. Speed to market was huge with 3D printing, because if we have to do a design and we send it to an injection molder or extruder, it's anywhere from 6 weeks to 20 weeks. We can get a part out of our 3D printer that can be 6 to 12 hours. It could be as short as 2 hours. From return on investment, the biggest part, like our one facility's got 91 different parts we make. On average, that part is $6,000 to $8,000 in tooling costs. So you take that times 91 parts, we're talking millions of dollars a year that we're not spending on tooling. We can put that money into assembly equipment on the shop floor.
With the Origin 2, we can hit really tight tolerances. The finished quality is extremely high end. The detail you can get is insane.
All of our parts have a part number printed right on them. If the shop floor runs out, they can call us up and say, hey, we need this part.
The plants will send us their inventory sheets of what they have on hand, and then I'll queue up the different builds here on the Origin 2, and then we'll print them and send them out.
We're not locked into conventional manufacturing processes. We needed a part that had a larger diameter hole going to small diameter hole inside of the physical part. With the 3D printer, we can model it up, draw it, and print it. On an injection molder, it would be very expensive if we can even get it done. So this is one of our new pivot doors. Quite a few parts in here are 3D printed. Several of the end caps in the part, end caps in the tubes. This is the ADA sill for that pivot door. So this is the end cap that goes in the part. This is a 3D printed part with the Stratasys number on it, or our part number on it. It gets slid into the end, and that's what finishes it off. This is so the nail fin of the window is rebuilt, so it goes right to the floor, so the air water structural can be certified on it. This is a 3D printed part that we use to help seal the bottom of our hinge doors. This part slides in here, and then the door frame goes together, and that allows us to stop the water from getting into that hollow. There's no way we have the success we have today without the Stratasys 3D printers allowing us to move to market quicker and get everything going.